Hi guys, so we're going to pick up with part 2 of solving absolute value inequalities. We did all the way up to number 3 here in the first part, so we're going to start with number 4. All right, so you can see the difference here where the absolute value is not isolated. So what we need to do first is always get that absolute value isolated before we start setting up the positive and the negative case. So to do that here, we're going to add 3 to both sides. So that gives me the absolute value of 2x plus 1 is greater than 9. Now I can go ahead and set up my positive and my negative case. So for my positive case, I can just go ahead and get rid of the absolute value. And then for the negative case, remember that you need to flip the inequality and negate the right side. So you need to flip the symbol, and then you need to negate that right side. So now I'm ready to go ahead and solve these. So I subtract 1. That gives me 2x is greater than 8. And I can go ahead and divide by 2. So I get x is greater than 4. On this side, I can subtract 1. Get 2x is less than negative 10. Divide by 2. And I get x is less than negative 5. Now remember, it's easier to graph this and see what kind of problem they have. You have an and or an or statement. So if I go ahead and graph this, I have negative 5 over here, and I have 4 over here. So greater than 4 is open circle, because I don't have the equals going to the right. This less than open circle, because I don't have the equal sign, and goes to the left. So they go in opposite directions, so that makes this an or statement. In the way that we write that in inequality notation, not in interval notation, we have this interval right here. So that's gonna, remember that's negative infinity all the way to the left. So negative infinity all the way up to negative 5 with parentheses because we're not including it, union, and then the next interval here, picking up with 4 but not including it, going all the way up to infinity, because remember all the way to the right is infinity. So this is your interval notation, this would be your number line, and then this would be your inequality notation. All right, let's look at the last 2 problems here. We'll pick up with number 5. So we see we have a lot more on the left side with the absolute value, so we want to make sure that we get rid of that first before we do anything. So I'm going to go ahead and add the 10. And I also get students to ask me if I can distribute into the absolute value, and you cannot do that. We cannot distribute into the absolute value, so you want to make sure you're not doing that. So this would be negative 7 times the absolute value of 7 minus 3x is less than negative 28. Now we're going to divide by negative 7. But what happens if you multiply or divide by a negative? You have to flip the inequality. So this becomes 7 minus 3x is now greater than positive 4. So you see that right there, we flip the inequality symbol. So now I can set up my positive and my negative case. So I have my positive, negative. I have 7 minus 3x is greater than 4. And then here I have 7 minus 3x is less than negative 4. I know we flipped it over here. We flipped the symbol because of the negative, but now we're setting up the negative case. So again, we have to go ahead and flip that. So flip the symbol, change the sign. Now I'm ready to go ahead and solve these. So I'm going to subtract 7. That gives me negative 3x is greater than negative 3. Divide by negative 3. And look what happens again. I got to flip it again. So x is less than 1. So 3 times I had to flip this so far. Second part, the negative case. Subtract 7. I get negative 3x is less than negative 11. Now I'm going to divide by negative 3. Again, if I'm dividing by negative, what does that mean? I got to flip it. So x is now greater than 11 thirds. So let's go ahead and take a look at this on a number line and see what we're dealing with. Do we have an AND or an OR statement? So 1 is going to be over here. 11/3 is over here because 11/3 is greater than 1. So if we're going to be less than 1, it's an open circle going to the left. Greater than 11/3, open circle going to the right. So this is clearly an OR statement. So this is our inequality notation right here. This is our number line. So for our interval notation, we need to do each interval separately. So remember, all the way to the left is negative infinity, all the way to the right is positive infinity. So this is going from negative infinity all the way to 1, but not including the 1, so it's parentheses, union. So then the next interval is right here. So 11/3, but not including it, all the way up to infinity. All right, so that is number 5. So again, hopefully you can see all that there. This would be the interval notation. So now let's pick up with the last one for this video, this part, second part of solving absolute value inequalities. And let's take care of this one, number 6. So this is tricky. So I'm going to add the 2. And that gives me negative. I still have that negative here. Absolute value of 7x plus 4 is greater than or equal to -3. Now I'm trying to get the absolute value by itself, not the negative absolute value. So I have to divide by -1, because this means -1 times the absolute value. So the opposite of it is to divide by -1. Now what happens when you divide by a negative? I get 7x plus 4. Flip the inequality. Remember, you got to flip the inequality if you're dividing or multiplying by negative. So now I can go ahead and set up my positive and my negative case. So for my positive case, I have 7x plus 4 is less than or equal to 3. And then for my negative case, I have 7x plus 4 is now greater than or equal to -3. Remember, you need to flip and then change the sign. So let's go ahead and solve these. I'm going to subtract 4. And I get 7x is less than or equal to -1. And then divide by 7. So x is less than or equal to -1/7. And that's okay. A lot of students get fractions and they think it's wrong. It's okay if you get fractions. So here I'm going to subtract 4. So I get 7x is greater than or equal to -7. And I'm going to divide by 7. I get x is greater than or equal to -1. So let's go ahead and take care of this on a number line. See what we got. So -1 is over here, and then -1/7 would be somewhere over here. The key thing that you understand is -1 is to the left of -1/7 on a number line. So if we're going to be less than or equal to -1/7, that means it's a closed circle because we have the equal symbol, and less than means we're going to the left. So this is clearly going to be an end statement. They're going to meet in the middle, because greater than or equal to -1 is a closed circle going to the right, so you can see it meets in the middle. Well, how do we write this inequality if we have an end statement? So this means it is -1 is less than or equal to x, which is less than or equal to -1/7. Okay, so this is your number line. This is how you would have your inequality. You can't just put an end between those, because that's typically not how it's written. It's written as a compound inequality. So you just follow your number line and you can easily write your inequality that way. Well, we're also going to follow the number line to do the interval notation here. We're including these two values. So bracket all the way up to -1/7, and then a bracket there. All right, well, this finishes up the videos for solving absolute value inequalities, and we will pick up with the next video.